Hey there, thanks for stopping by. Today I want to just cover the process of getting a temporary furnace set up. I'm just going to talk you through kind of the few things that you need to know to get a gas furnace temporarily set up for a situation where you have some kind of construction work going on where you need some heat. So what we have here is an old beater furnace that has been relegated to the duty of temporary furnace service. So this is just a high efficiency, maybe like a 95% efficient gas furnace. Now this particular one is converted to propane. So that's going to be thing number one, is making sure that you have your gas valve and your furnace converted to propane if you are using propane. Obviously, if you're using natural gas, then that's going to be natural gas. But a lot of times with temporary furnaces, you may not have your natural gas lines brought up to the building that you're working on yet, or you just don't have natural gas available at all. So with a propane conversion, I'm just going to tell you what it involves. There's a couple of springs inside here. This is a two-stage furnace, so it has two springs. So sometimes you'll replace both of those springs, but if it just has one cap like this, you just need a single spring to convert it from natural gas to propane, and then you'll need different orifices. These brass little orifices you see up in there, those are different size for natural gas than they are for propane. So you need a conversion kit to convert whatever model furnace that you have. So look at the model number, look it up. You should be able to order a propane conversion kit, and then you will be good to go once you do get it converted. Now for our gas line, in this instance, we actually had a flexible hose here. It's an air hose that we're using temporarily for the furnace because we originally had the furnace over on that corner of this building, and that's convenient, gives you some flexibility. The furnace needs approximately 11 inches of water column for the pressure coming into your gas valve. So you want to make sure that you hook something up that is the correct pressure feeding your furnace. And then obviously go ahead and check and make sure that you have no leaks on any of your fittings, and be 100% sure that you're good to go before you fire it up. Now, depending on what you're using the furnace for, you can use either one or two vent pipes. In this case, we're just using one. We weren't doing anything in here that was extremely dusty. We're not doing drywall or anything. If you're going to be doing drywall and you want a temporary furnace, you should probably run your second pipe for a direct vent furnace setup. So we just run a second 2-inch PVC pipe up and out next to the first one, about a foot over or so. It can even be a little bit closer and it'd be fine. Just put an elbow on the intake facing down, and your exhaust can just go straight out. It's oftentimes helpful to have a couple of Ferncos or flexible rubber couplings to connect your vent going up and out. That gives you the option of disassembling it if you need to move it again. Alright, the furnace is coming. I'll just talk you through how these furnaces work. Combustion blower comes on, and then the igniter comes on after that. Once it's confirmed with the pressure switch that the combustion blower is running and that the vent is clear. So we should see the igniter start to glow. There it is. And then a few seconds later we'll hear a click, and that'll be the gas valve energizing, allowing the burners to light. Should happen here in a couple seconds. Goes. And then there's usually a little bit of a delay before your main blower, which is down here in the bottom, will come on, probably about 15 seconds or something like that. And that brings me over to this side of the furnace here. You can see we have a filter rack assembly installed on the side of this furnace. And making sure that you have a good filter, especially in a bad environment like what a temporary furnace is going to be set up in, is really important. There comes the main blower. Okay, I'll shut this thing off here for the moment. Oh, I'm just going to unplug it, I think. Okay, so yeah, having a good filter installed is important to keep drywall dust and stuff out of it as much as possible. And then up above the furnace here, the plenum of the furnace. Now you would think that you could maybe even just skip this entirely, but this is actually really important. Basically, if you don't have this on there, the airflow going through this furnace is going to be way more than it should be. These things are designed to have a certain temperature rise across the heat exchanger, so if you have no ductwork on top of it and it's totally open, then it's going to be moving a ton of air through there, and it might cause condensation in the primary heat exchanger. So if you build some kind of a small plenum and then just have an opening that directs the air, sometimes you could add multiple vents. Like if you wanted this to be the really nice temporary furnace where you move it around, you could add a vent in each side and then turn the ones on that you want. You can see right here, there was another piece on here before, but right now I'm using this dustpan to direct the air back down towards the floor. Anyway, so put some kind of a plenum to reduce the amount of air going through the furnace so that you don't overcool that heat exchanger. And you can always check your temperature rise. So see right here it says the max, or the temperature rise should be 30 to 60 degrees Fahrenheit. So the way you would test that is you just test the temperature of the air coming in and the temperature of the air coming out and make sure it's in that 30 to 60 degree range. If it's too low, if you have like a 20 degree temperature rise, then you know you're moving too much air. If it's like a 70 degree temperature rise, then you know you're not moving enough air. So that's a kind of an easy way to check to make sure that you've set it up properly. Okay, so for wiring the furnace, you're going to need a drop cord of some kind, and furnaces typically require a 15 amp 110 volt circuit, which means you could use a 14 gauge drop cord. So use a drop cord and then make sure that you have your ground prong. I'll show you what those connections look like inside of the furnace here where this connects. Okay, so right here is the wire that comes in from that drop cord. Comes through the side of the furnace, and then we have our just 3 connections. We have our 110 volt line voltage. This is the hot wire that comes in, so that's just connected up to the like color that feeds the furnace. Same thing for the neutral, white wires connected together, and the ground wire connected right here. Some furnaces will have just like a grounding screw attached like onto the frame, so if you don't have a green wire, it probably means that you're supposed to take that ground wire and land it like directly on the cabinet inside of that box. But in this case we do have a wire that we just connected onto. So it's very, very important that you do not reverse the polarity. You need your hot to be hot and your neutral to be neutral. And then it's also very important that you have a good ground. If you don't have a good ground, the furnace will not operate with most modern furnaces. So make sure you have good connections through and through for your 110 volts. And we have that clamped securely going through the sidewall of the furnace. Now you obviously need something to control the furnace. In this case we have a little digital thermostat that's just mounted out here near the return air. Now this isn't optimal. It might cycle a little bit faster than we want it to, but it works good enough for what we need it for. This is just a heating only thermostat, so I'll show you the way it's hooked up inside of here. We have just this wire here that's going to that thermostat coming through the sidewall, and then it just comes down, hooks onto the control board. And you can see right there, we just have it hooked to the R and the W. So R right here and W right next to it. When you cross those two, that will start the furnace. You see this other wire right here? That's actually just a twisty tie. That is our way of being able to short that out easily. We can just directly cross the R to the W, and then the furnace will run continuous. And sometimes we have to do that because if the furnace or if the room is below 32 degrees, when you first start the furnace, your thermostat, if it's a smart thermostat, will not turn on because it's protecting the furnace because it thinks that the furnace froze, which isn't necessarily the case. So that's why we have that little jumper wire there on the ready in case we do need it. But just the R and the W, and then those come over to the thermostat. I'll pull it off here really quick and show you what it looks like. So right underneath this cover, should be able to see that this is just hooked to the R and the W on the thermostat itself. So that is all you need to hook up if you're doing a heating only setup. So that should pretty much cover what you need to know about the electrical portion of your temporary furnace. Right here at the top of this bottom compartment, there's typically a door switch, and that's what this is right here. So if you turned it on with this cover off down here, you would not be able to make the furnace run unless you hold in that door switch. But it's probably better to just put the cover on it so nobody gets their hand inside of that blower right there. That's another reason why you should put a filter rack on the side, is it keeps it safe, keeps people safe from getting exposed to that squirrel cage blower. The other reason that air filter is really important is that the secondary heat exchanger inside of these furnaces is typically like a coil. And so if you don't have a filter in there, it's going to plug up that secondary heat exchanger, and then your furnace is going to be, it's not going to work until you take and slide that blower out of there and clean that secondary heat exchanger. All right, the last thing you're going to have to deal with is the condensate. So all high efficiency furnaces are condensing gas furnaces, meaning that they produce condensate when they run. So moisture will come through this tube and this tube right here, which comes off of the secondary heat exchanger back behind this blower, and that runs into what should be a trap on the side of the furnace. Now this is a modified trap. This isn't the original one that was on here because the original one got broken off and lost somewhere. But in any case, it's very similar. Usually this trap will be internal. So you'll have some kind of a trap inside of here with one pipe coming out of it. But in this case, we have it on the outside. So these two copper pipes go down into this trap. So they're down in the water, and then the water, once it reaches this level, runs out our drain tube over towards the floor drain. So you will have to deal with condensate. You'll have to have a place to catch that. Sometimes if we don't have a drain available, we'll just put like a 5-gallon bucket underneath this, and then we can run the furnace for, just empty your bucket once a day, and then you're fine. So that pretty much summarizes what you need to know for getting a temporary high efficiency furnace set up for temporary use, whatever the situation may be that you are facing. A couple other thoughts. If you are going to be running this in a cool environment all the time, like if you're going to keep the thermostat set at 40, it might not be the best option to use a high efficiency furnace. Check the installation instructions or contact the manufacturer about the temperatures that the furnace can operate in, because if you operate at a lower temperature, there's a chance, I think it's like below 50 or 55 degrees, if you're going to run with a return air temperature at that temperature all the time, then it will cause condensing inside of the primary heat exchanger, and it will rust out the heat exchanger prematurely. So if you're going to run your furnace in a colder environment, then I'd recommend going with just one of those regular garage heaters that don't have condensate, or one of those ones that just like mounts on the ceiling. Something like that. It's like an 80% efficient furnace instead of 95% efficient like this one. The other thing with that is you could probably keep your garage at 55 degrees with a high efficiency furnace for the same price. Well, you'd have to do the math, but the efficiency gained with the high efficiency, you can just keep your garage warmer instead of keeping your garage colder with one of those lower efficiency ones that you can pick up that mount on the ceiling that are like 80% efficient. So keep that in mind when you're choosing what type of heater. Now the other thing to think about is if for temporary heat, this type of a furnace is going to exhaust out to the outside, and it has condensate as a byproduct of it running. Now you have those NIPCO heaters, those propane heaters that just burn propane and blast it straight into the air, and there's no vents. The bad thing about those is they produce a tremendous amount of moisture that goes straight into the air. So if you want a dry work environment for whatever you're doing, you're not going to want to use a NIPCO style heater. You're going to either want an 80% efficient furnace of some kind or a high efficiency furnace like what we have here. Put any comments or thoughts that you have right down below this video in the comment section. Oftentimes if I miss something, you guys will correct me, and everyone is better for it. I'll put a couple of videos right here on the screen if you want to keep learning about propane and HVAC type videos. And we'll see you over there in a few seconds. And yeah, thanks for watching. I'm gonna install a garage door over there. Not a garage door. I'm gonna install a walk door over there now. So that's my next project. So wish me luck, because it's like, I don't know, it's like 5 degrees outside right now here in Minnesota. All right, see ya.